Hello guys, welcome back to my channel. I am Yoga, currently pursuing my second sem in CSE in Sri Venkateshwara College of Engineering, Bengaluru. Today in this video, we are going to discuss about the subject chemistry and the subject code is BCHES202 and my topic is corrosion. So let's start our topic. Introduction to corrosion. Corrosion is the process of deterioration of materials, most commonly metals, due to chemical reactions with the environment. It can lead to structural damage, reduced functionality, and aesthetic degradation. There are several types of corrosion, each with its own distinguishing characteristic and causes. Wet corrosion occurs in the presence of moisture such as water or humidity, leading to the formation of rust and other metal oxides. Whereas dry corrosion, on the other hand, occurs in the absence of moisture and is caused by gases, chemicals, or other environmental factors. What is wet corrosion? Wet corrosion, also known as chemical corrosion, is a process in which a metal is deteriorated by a reaction with its environment, particularly in the presence of water. This type of corrosion is dependent on the presence of electrolyte and oxygen, with the metal surface serving as the anode, and the cathodes can be treated as non-metallic particles or as the metal itself. This process often involves the formation of rust, as in the case of iron and steel, and the tarnishing of soil. The presence of moisture in the environment is a key factor in the occurrence of wet corrosion. It is important to understand the mechanisms of wet corrosion and the factors that contribute to its occurrence in order to mitigate its effects on various structures and metallic components. Examples of wet corrosion: rusting of iron and tarnishing of silver. What is dry corrosion? Dry corrosion, also known as chemical corrosion, occurs when metals react with the environment in the absence of moisture. Unlike wet corrosion, which involves the presence of a liquid, dry corrosion can occur through exposure to gases such as oxygen and sulfur compounds or under high temperature conditions. This form of corrosion often leads to the formation of oxides, sulfides, or other compounds on the metal surface, resulting in degradation of the material over time. One common example of dry corrosion is the oxidation of metals, where the metal combines with oxygen to form metal oxides, such as rust on iron or tarnish or copper and brass. In industrial settings, dry corrosion can have significant implications for the structural integrity and safety of metal-based components and structures, making it crucial to understand its mechanism and take preventive measures to mitigate its effects. The prevention of dry corrosion often involves the use of protective coatings, control of environmental conditions, and material selection based on resistance to specific corrosive agents. Examples of dry corrosion: oxidation of metals and sulfidification of metals. Key differences between wet and dry corrosion. Wet corrosion. Wet corrosion occurs in the presence of a liquid, typically water, that facilitates the electrochemical reaction between the metal and its environment. The process of wet corrosion can lead to the formation of rust, specifically in the case of iron and steel, which can weaken the metal and ultimately cause structural damage. One of the key factors in wet corrosion is the presence of water, which acts as an electrolyte, allowing the flow of charged particles. This can accelerate the corrosion process and make it more rapid compared to dry corrosion. Dry corrosion. Dry corrosion, also known as oxidation corrosion, occurs in the absence of a liquid phase. It is driven by chemical and gaseous interactions with the metals environment. Oxidation of metals is a common form of dry corrosion where the metal reacts with oxygen in the air, forming a layer of oxide on the surface. Another example of dry corrosion is sulfidification, where metal interacts with sulfur compounds in the air, resulting in the formation of metal sulfides on the surface. Unlike wet corrosion, the absence of liquid can slow down the corrosion process in dry corrosion scenarios. Importance of understanding corrosion in various industries. Structural integrity. Understanding corrosion is crucial for maintaining the structural integrity of buildings, bridges, and other infrastructure. Corrosion can weaken metal compounds, leading to costly repairs and safety hazards in various industries. E- Equipment reliability. In industries such as manufacturing, energy production, and transportation, the reliability of machinery and equipment is vital. Knowledge of corrosion helps in preventing equipment failures and prolonging the lifespan of crucial industrial assets. Environmental impact. Corrosion can have significant environmental implications by causing leaks, spills, and contamination. Understanding corrosion is essential for minimizing environmental damage and ensuring sustainable practices in different industries. Economic consequences. The economic impact of corrosion industries is substantial. By understanding corrosion, business can minimize repair costs, downtime, and production losses, contributing to overall profitability and economic sustainability. Preventive measures for wet corrosion. Proper coating. Implement high quality coating such as paint or epoxy to act as a protective barrier on metal surfaces, preventing direct exposure to moisture. Cathodic protection. Install sacrificial anodes or utilize impressed current systems to protect metal structures from corrosion by diverting the electrical current away from the metal. Controlled environment. Maintain appropriate humidity levels and temperature controller in indoor spaces to minimize the impact of moisture on metal surfaces. Preventive measures for dry corrosion. Protective coatings. Applying the protective coatings such as paints or polymer films forms a barrier between the metal surface and the surrounding environment, preventing exposure to dry corrosion agents. Corrosion inhibitors. Using corrosion inhibitors such as chemicals or compounds that can be applied as a thin film helps to slow down the oxidation process and protect the metal from dry corrosion. Proper storage and handling. Storing metals in controlled environments with regulated temperature and humidity levels can mitigate the impact of dry corrosion as exposure to moisture and corrosive gases is minimized. Conclusion and summary. Corrosive is a pervasive issue across various industries, leading to significant economic and safety concerns. Through this presentation, we have explored the different forms of corrosion, including wet corrosion and dry corrosion, along with the respective examples and preventive measures. It is evident that understanding the mechanisms and factors contributing to corrosion is crucial for implementing effective prevention strategies. From the rusting of iron to the oxidation of metals, we have delved into real world scenarios where corrosion has tangible consequences. By recognizing the distinctions between wet and dry corrosion, industries can tailor their corrosion mitigation efforts to suit the specific challenges they face. With this comprehensive overview, stakeholders and professionals across industries can better comprehend the importance of proactive corrosion management and its potential impact on operation and infrastructure. Thank you guys for watching my video. Please do like the video and subscribe.